You already know the story. 66 million years ago, asteroid 10 kilometers wide slammed into Earth at 70,000 kilometers per hour. The dinosaurs died, we survived, and somewhere in that story humanity found comfort. We told ourselves, Earth is resilient, Earth recovers. No matter what hits it, life finds a way. That belief feels solid. It feels earned. It is also incomplete because the only reason anything survived had nothing to do with resilience. It had to do with luck. Luck so preciso, mathematically improbable, that if you ran Earth's history 1,000 times over, most versions end in silence. But here is what nobody asks. How many times before that asteroid did Earth almost not make it? The answer will change how you see this planet forever. 4.5 billion years ago, Earth did not exist. What existed was a spinning disk-off gas and dust collapsing under its own gravity, hot, chaotic, directionless. And inside that chaos, small pieces of rock began finding each other. Not gently, violently. This is how Earth was born, not formed, assembled through destruction. And it almost ended before it properly began. A planet the size of Martian, the young Earth directly. Scientists call it Theia, and when Theia hit the temperature of Earth's surface, he reached higher than the surface of the sun itself. Everything burrized, the atmosphere that had barely formed, the crust, the upper mantle, all of it gone in seconds. That collision should have ended Earth. By every model we runin impact, that size should have either destroyed the planetor, sent it spinning so violently that no stable orbit was possible. Instead, something unexpected happened. The debris gathered in orbit. Gravity pulled it together, and it formed the Moon. The Moon stabilized Earth's axial tilt. Without that stability, Earth's seasons would be catastrophic. No stable climate, no stable chemistry, no path to complex life. The collision that almost killed Earth created the exact system that made life possible. But that answer immediately opens a deeper problem. Because the Moon was not enough, for 200 million year solar planet was struck continuously by asteroids and comets raining in from the outer solar system. The surface was not a surface, it was a target. Scientists believed for decades this period was purely destructive. That assumption fails immediately when you look at what those impacting bodies carried inside them. Water, carbon, organic molecules. The bombardment that should have sterilized Earth was simultaneously delivering the ingredients for life. Destruction and creation happening at the same time, inseparable from each other. But this is where it breaks. 2.4 billion years ago, a single bacteria learned to photosynthesize. This sounds like progress. It was initially a catastrophe. Oxygen was poisonto, almost every living thing on Earth at that time. The Great Oxidation event killed the majority of life on the planet. A mass extinction caused not by asteroid, not by volcano, but by the waste product of a single microscopic organism doing exactly what it evolved to do. And that oxygen catastrophe cooled the planet so severely that Earth froze completely. Not partially, completely, Ice from pole to equator, oceans frozen kilometers deep. A white planet reflecting sunlight back into space, making itself colder with every passing day. Scientists call it Snowball Earth, and the most terrifying detail that most people never hear: we do not fully understand how Earth escaped it. Volcanic activity beneath the ice's lowly released carbon dioxide over millions of years. The greenhouse effect eventually broke the freeze. But the margin was razor thin. A slightly different volcanic rate, a slightly different axial position, and the freeze becomes permanent. Earth becomes Mars forever. But even escaping the freeze did not guarantee what came next. 250 million years ago, great dying happened. 90% of all species on Earth gone in a geological instant. Not an asteroid this time. Volcanic eruptions lasting 1 million years continuously. Oceans acidifying. Oxygen levels collapsing. The most complete destruction of complex life this planet has ever experienced. Life survived only barely in isolated pockets, in deep ocean refuges, in places the poison had not yet reached. The 10% that remained became the foundation for every living thing alive today, including you. Which brings us back to that asteroid, 66 million years ago, 10 kilometers wide. We know the story. But here is what the story misses. The asteroid hit a specific geological formation, a shallow shelf packed with sulfur-rich rock. When the asteroid vaporized, that rocket released sulfur dioxide into the atmosphere at a scale that made everything times worse. If it had hit the open ocean, the deep plains, another continent, the extinction would have been smaller. More species survive. The mammals that replaced the dinosaurs face more competition. The path to everything that followed changes completely. The specific horror of that extinction depended on where exactly one rock happened to land. And here is where the question collapses. We call Earth resilient. We say life finds a way. We look at 4.5 billion years of survival and call it strength. But what we are actually looking at is a chain of near misseso long, and so precise that the word resiliencedos not begin to cover it. Earth did not survive because it was strong. Earth survived because at each moment when everything could have ended, something held an angle of impact, a volcanic rate, a frozen ocean that thawed by the narrowest margin possible, a bacteria that poisoned the world and accidentally saved it, an asteroid that high-toned specific patch of rock and made the worst possible outcome somehow survivable. Each survival depending on the one before it, and the question that remains, the one that never resolves, is this. We know what survived. We have no way of knowing how many versions of this planet did not. How many Earths how many solar systems made it through bombardment and then stopped, survived their own frozen period and then stopped, got hit at a slightly different angle and then stopped. We have one data point, one Earth, one chain of survival we can actually read. And we call it the story of how life persists. But it may simply be the story of how unlikely permanent actually is. The question was never how did Earth survive? The real question is how many did not? And that question has no answer yet.